Now here's where the questions get a little bit more complicated. So you have x to the third plus 4xy squared minus 27 equals y to the fourth. Find dy dx. The hard part is right here, because what you have here is you have a product rule. You have 4x times y to the second, and that's a product between two variables. So you're going to have to do a product rule to find the derivative of this piece. So let's work through it. The derivative of x to the third is 3x squared. The derivative of 4xy squared, I'm going to bring that to the side. So I'm going to do right over here. So if I have 4xy squared, I'm going to let u be 4x and v be y squared. U prime is 4, v prime is 2y. Remember, we're differentiating with respect to x, right? So it's going to be 2y y prime, or 2y dy dx. You choose what notation you want to use. I'm going to use y prime. So now the derivative of this middle piece is product rule. U prime v plus uv prime. So I'm going to just substitute the terms in here. U prime v plus u v prime. That's the derivative of the whole second term from the top. The derivative of 27 is 0. The derivative of y to the fourth is 4y to the third dy dx, or y prime. I'm using y prime, so I'm going to write y prime. So first step, differentiate everything with respect to x. We did that. Second step, collect all your dy dx's to one side of the equation, or in this case, we're using y prime. So I look to see where my y primes are, and remember, when you remember, all your terms are separated by additions and subtraction symbols. So this doesn't have a dy dx or a y prime. This one does not have a y prime. This whole piece does have a y prime. And this whole piece has a y prime. So I'm going to take the 3x squared and the 4y squared. I'm going to bring it to the right side. I'm going to take the 4y to the third y prime and bring it to the left side. I'm also going to do a few other steps at the same time. 4 times 2 is 8, so I'm going to write this as 8xy y prime when I bring it down here. So here we go. 8xy y prime. 4 times 2 is 8x times y prime. Minus the 4 y to the third y prime. Now these two terms here we're bringing to the right side because it does not have y prime with it. So minus 3x squared minus 4y squared. Factor out y prime. 8xy minus 4y to the third. Again, you just take out the y primes. 8xy, 4y to the third. Keep the right hand side the same. And your derivative, or dy dx, or your y prime, is negative 3x squared minus 4y squared. You're dividing by that parentheses, so divided by 8xy minus 4y to the third. And that is your dy dx, or your y prime, depending on how you want to notate it. So this one's a little bit more difficult than the last two because you had to do a product rule inside. So just break it up like you had done before. Think of it as if it was like when we had e to the x times x. It's just like the same idea, only now you have more than just one variable. You have x and y. So if you need to pause the video and go back and review it, do so that way you can understand how we work through this question. Let's try one more. Find the slope of the curve x to the third equals parentheses y minus x squared squared at the point 1, 2. Now the foundation of this question, slope of a curve at a point, you've been working with for some time now. For slope of a curve, remember that when you find your dy dx, you find your derivative. That gives you the general equation for your slopes of curves at any point, but they specifically give you at a point, so you're going to find dy dx at 1. And that'll give you your slope. So you say, okay, I gotta find dy dx. How am I finding dy dx? Implicit differentiation. So before we even begin, the derivative of the left side is a regular x to the n rule, power rule that we've worked with. The derivative of the right side is going to be chain rule. So outside function times the derivative of the inside function. Now when you take the derivative of the inside function, that's where your dy dx turns up. Okay, so let's try it. X to the third is 3x squared. The derivative of the outside function is 2. Keep the parentheses exactly the same inside the parentheses that you're writing. And then you take the derivative of the inside. So derivative of the inside, the derivative of y is 1, y prime, or dy dx. And the derivative of negative x squared is negative 2x. Now what I usually get as a question is, when you take the derivative of the outside function, why didn't you put another y prime? Well, realize that when you take the derivative of the outside, you're not taking the derivative of a y. You're just taking the derivative of the outside function. So it's going to be 2 parentheses to the 1. And the derivative of the inside, derivative of y is 1, but because you're taking the derivative of y with respect to x, you need dy dx or y prime. And the derivative of x squared is 2x. Now, collect your y primes. Now here's where it's tricky. Your y prime is stuck. It's stuck inside of this parentheses. But notice that this term and this term are multiplied with the whole parentheses that has the y prime. So in order to start to break away the pieces that are connected to the y prime, you can bring this all over to the other side by doing the opposite operation that's connecting that parentheses. And the opposite operation for multiplication is division. So we're going to divide 2y minus x squared to the left side. So we get 3x squared all over 2y minus x squared equals, all of this cancels out, and leaves us with y prime minus 2x. And you're almost there, right? Because you want to solve for y prime. So add the 2x to the left side. Don't worry about you having a fraction plus a term. That's fine. So you're going to get 3x squared all over 2y minus x squared plus 2x is y prime. Don't try to combine anything. Remember what the question was asking you for. It was asking for the slope of the curve at a point, and you specifically want to know about the x value. If they were asking for the equation of the tangent line at the point, then you would use both the x and the y. But they're just asking for slope. So remember, the slope is when you substitute in the x value into the derivative. So we're just going to do that now. We're going to get 3 times 1 squared all over 2 times, and then you say, wait, we actually need the y value, because when you substitute in here, it's not just y. Sorry, it's not just x, but it's x and y. So you're going to substitute in the y value, which was 2 minus 1 squared plus 2 times 1. Just to check that. 3 times 1 squared, 2 times the y value, 2 minus 1 squared, plus 2 times 1. So because we're working with both the x and the y, we actually could fix this notation to state 1, 2. That's the point that we're substituting in. When we evaluate this, we get 3 all over 2 minus 1 squared is 1 times 2 is 2 plus 2. And that becomes 3 all over 2 plus 4 all over 2. So the slope of the curve at that point is 7/2. I recommend pausing the video, going back, making sure you understand how we got through all of this material. Again, differentiate everything with respect to x. Collect all your y primes, your dy dx's, to one side. Factor out that y prime, and then solve for it. If the question asks for slope at a point or equation of tangent line, you have to substitute the x and y value into the derivative in order to find that value. In the same format, same procedure every time.